Hi everyone, and welcome to my talk on the development and assessment of survey items with the Survey Quality Predictor. In this session, I will introduce you to a practical hands-on tool that is completely free to use. It's called the Survey Quality Predictor, or also short SQP. And it basically helps you predict the quality of your survey items, and it supports you in designing better questionnaires. Before we get into the topic, let me just briefly introduce myself. My name is Lydia Repke, and I work at GESIS here as the lead of the team Scale Development and Documentation. This team is within the Department of Survey Design and Methodology. I'm also the product manager of SQP, and my research focuses on questionnaire design and data quality, but also on substantive topics involving social networks, well-being, and migration. In my work, I often support researchers in designing better questionnaires, and that's exactly where tools like the Survey Quality Predictor come in. They sometimes say that designing questionnaires is an art, or at least I like to believe there is some truth in that. But the good news is it also is something that you can learn through experience. And to make this process of designing a good questionnaire or good questions a bit more scientific and less reliant on guesswork, let's say, Willem Saris and colleagues developed the Survey Quality Predictor. So what can you expect from today's session? Here's a quick overview of what we will cover. First, I will walk you through the different characteristics that survey items can have. Then we'll look at how to estimate and predict the quality of survey items. And finally, I will show you how to use the Survey Quality Predictor to support your own questionnaire design. Okay, let's get started. Before we really dive into everything, we need some basics. And these are questions such as, what actually determines the quality of a survey item? What makes an item work well? And what makes it fall short, maybe? So these are the kinds of questions we need to ask before we can begin to improve our item design. What you see here is an example of an item, how it is used in the European Social Survey, in the ESS, and it states, on the whole, how satisfied are you with the present state of the economy in country XYZ? Still use this card. So this is the item, your request for an answer, and then you have an answer question on the bottom, an answer option, answer scale on the bottom, which ranges from extremely dissatisfied to extremely satisfied. So when designing this particular survey item, there are all kinds of decisions that you have to take, or that you take either consciously or unconsciously. And I just want to show you a little bit what type of decisions they are that you potentially have to take. For example, you could think about whether you want an interviewer instruction in the case of a face-to-face survey, which is here, still card 9, is an instruction for the interviewer to use a specific card, a specific show card. You could also think about whether you want an instruction for the respondent, which here in this case is still use this card. You could phrase or formulate your survey item or design it in a way that it's part of an item battery or not. You could think about whether you want to ask your question in a balanced or an unbalanced way. So in this case, it's unbalanced because we're only asking about satisfaction. If it were a balanced question, it would state something like, how satisfied or dissatisfied are you with, and so on and so forth. So there you would have two different poles. You would have a bipolar way of asking this question, a balanced question. And then this is maybe something you do not decide on very, let's say, consciously, is the number of words. But of course, when designing your question, you might think about how complex your question is going to be or not. And maybe also the concept that you're asking about is complex in itself and you need a longer question. So it's not to say that long questions are per se bad, but I mean, they have an influence of how people digest these questions, such as also things like the number of nouns or abstract nouns, or whether there are subordinated clauses and things like that. Also very important are decisions that refer to your answer scale, such as how many categories do you want to have? Is it an 11-point scale, a 5-point scale, and so on and so forth? Do you want to label your scale, so every single point, or just partially label it? Do you want to offer a don't know option, and so on and so forth? So this is only like a short glimpse on potential decisions that are important. Having said that, some of these choices are dependent on the study itself, and in some choices, it's your own freedom. You can choose certain things. So, for example, the domain and the concept, so what you're asking about, is basically given by your study. If you have a study on political trust, well, you have to ask something about political trust. But you're free in the way you formulate your question, in what way you design your response scale, and also some additional components, such as whether you want to have an introduction to your question, or what the data collection mode of your survey in general is, and so on. Why do we have to bother about all these different characteristics? Well, very simple, because all these decisions have an effect on the response behavior, and as such also influence the quality, the measurement quality, or the measurement error. I brought you here just as a small reminder the 4-step model of Tourangeau, of how people basically arrive from seeing this question to actually getting to an answer. And in the first step, they have to understand what you're asking. They have to comprehend the question. In the next step, they have to retrieve the information that they need in order to answer your survey item. And based on this information that they retrieve, they have to come up with a judgment and then later translate that into a given response scale. So what usually sounds as something very simple is actually not that simple on the cognitive level of answering a question. So let's say you have a concept, but still there might be many different ways of how you could potentially measure a certain concept. And the big question here is, how do you decide which question or which measurement method actually captures the concept you're interested in best? So here in the following, I'm going to use the example of risk of sanction as a concept. And I present you one version, which was fielded in the European Social Survey, round 5, stating, now, just suppose you were to do any of these things in England. Using this card, please tell me how likely it is that you would be caught and punished if you made an exaggerated or false insurance claim. Not at all likely, not very likely, likely, very likely. You could have, however, also asked like this. Now, some questions about how likely it is that you would be caught and punished if you did certain things in England. Please use this card to answer, where 1 is very unlikely and 4 is very likely. How likely is it that you would be caught and punished in England if you made an exaggerated or false insurance claim? And here now you have the scale that ranges from 1, very unlikely, to 4, very likely. While several things have changed, and of course the wording has changed, also in terms of more formal things that have changed within these two versions is the introduction, the instruction, and also the answer scale. Does it make any difference? And if yes, what difference does it make? What I'm presenting you here is a screenshot already from SQP, from the software, where the two different versions of the items are, of this concept, let's say, these two different item versions are compared. On the left, in the left column, what you find is the different characteristics. And then in the second column, you find the, let's say, the values of these characteristics for your first measurement method, your first version. And then in the third column on the very right, you find the values for this second version. And wherever you see that there is some background color, so there is this blue and this pinky color, means that there is a difference in the coding. So, for example, the first measurement method had a scale which was fully labeled, right? So we had the 4 different points and they all had short text. And in the second version, we only had a partially labeled scale. The first and the fourth answer scale had some words. And then this, of course, makes a difference, according to SQP at least, in the quality prediction. Highlighted here, you see the quality of 0.578 for the first version and 0.507 for the second version. What do these numbers mean? Well, quality is something that ranges from 0 to 1, where 1 would mean that you're perfectly measuring what you want to measure. And, 0 obviously would mean you're measuring something completely different. But you might wonder also know whether these values are good values or bad values. It's not that direct or not that easy to interpret it in that way, but you can compare them with each other, and you see that the quality of the first version is higher than the one of the second. So consequently, based on these predictions, you would probably go for the first version of this for measuring this concept. Okay, so let's go into estimating and predicting survey item quality. Very often, it is assumed that the relationship between the concept of interest, so the thing that you actually want to measure, usually the opinion of the respondent, and the observed variable, so the thing that you use for measuring what you want to measure, so the actual survey question. So it's often assumed that this relationship between those two is basically perfect. And this means that our observed variable measures exactly our concept of interest. But is this really the case? Well, we know it's not the case, as observations are always subject to measurement error. And there are 2 types of measurement error. There is random error, which occurs by chance or mistake, right? So, for example, your respondent wanted to cross a 3 and accidentally crossed a 4 on your 11-point scale or something like that. And then whenever there is the presence of random error, this means that we need to distinguish between the true score and the observed variable. The true score is basically the true response to the survey question corrected for random error. And then the observed variable is the actual response to the survey question. Systematic error is the other type of error, affects the relationship between the variable of interest, so again, the opinion of the respondent, and the true score. So, for example, if you use a different method or a very particular method, such as a certain response scale. A person will respond differently if presented with an 11-point scale or with a 5-point scale. And then in this model here, the standardized effect between the true score and the observed variable is called reliability coefficient, and the standardized effect between the variable of interest and the true score is called validity coefficient. All of this together is also known as the true score model, as it was developed by Willem Saris and Frank Andrews. And according to the model, the quality of a survey question is basically the strength of the relationship between the opinion of the respondent on the one side and the observed answers on the other side. Or, put differently, it's the explained variance in the observed variable by the variable of interest. And it can be calculated by multiplying validity and reliability. And that's how you get the quality. Okay, so this is the theoretical framework behind estimating or the quality of survey questions, or how you could define the quality of survey questions. And to actually estimate it, very often the multi-trait, multi-method, or also short MTMM model is used. On the right side, you see basically a figure of what this model could potentially look like. And though it might look a little bit complex here, I want to break it down for you. This type of model involves basically measuring several related concepts or also traits by asking them multiple times using slightly different methods. So here, the big pinky circles with the T's, the traits, these are your related concepts. And a very common design, or basically the most common design, is a 3-trait by 3 method model. You see on the bottom of the figure these darker shaped circles. They are darker colored circles. These are the different methods, for example, 3 different answer scales. And then you have in the middle the TS, which is basically the true score, or the idea of measuring these 3 different or measuring, basically the 3 different traits with specific questions. So to give you an idea here, let's say trait 1 is satisfaction with country's economy, and then trait 2 with the government, and then trait 3 is satisfaction with a certain country's democracy. So these are all 3 different concepts, yet somehow related. And then you might have a question measuring those, and what you change is the answer scale. For example, the first method is an answer scale that ranges from 0 to 10. Then you have one completely labeled method with 4 different response options, and maybe a third method which consists of 6 different response options. And then you collect real data, and based on this real data and the model behind, you can then estimate the quality of these survey questions. As you see, this model is quite complex, and it also involves that people are being asked the same question in slightly different ways several times, and not only for one particular trait, but actually for 3 different traits. So this MTMM model obviously bears some disadvantages for respondents, being memory effects, obviously, and cognitive burden. If you have to answer all the time the same questions, you might remember what you answered before, and it is also very annoying, and so on and so forth. To overcome these disadvantages, the split ballot MTMM model was developed, which at least limits the repetitions for respondents. So the idea is here that not everybody has to answer all these 9 questions that result from this 3 times 3 matrix, but let's say version 1 and version 3, and the other one version 2 and version 3, and so on and so forth. But also this MTMM model has some disadvantages for researchers, in the sense that if you want to have an idea of how good your questions are, of course, it's impossible to repeat all your questions in a questionnaire just to get a sense of how good your question is. So it's just not possible. The questionnaire would get super long, super time-consuming, more expensive. Your participants will not like it, and so on and so forth. And this is now where the Survey Quality Predictor comes into play. The Survey Quality Predictor basically was developed for you as researchers to get, if you don't have the resources and the time to do these type of experiments or models, that you still get somehow a sense or idea or an, how would you call it, like maybe a very informed guesstimate, I call it, for how good your question is. Having said this, I want to make clear that there is a difference between estimating and predicting. So what I talked about here so far was estimation, which is basically the determining the quality of survey questions based on actual data, on available data, resulting from these MTMM experiments, which is one big part also in SQP. And then the second thing, prediction, is the idea that you use a model to forecast the quality of new survey items. And this is basically how SQP then operates, or what the idea of SQP is. Okay, so now we have talked about estimation and prediction. Let's dive into what the survey quality predictor actually is, because this is why you came today. The survey quality predictor is basically a web-based software that you can use to predict the measurement quality of survey items based on their characteristics, their formal and linguistic characteristics. It is also a searchable database of existing survey items with information on their measurement quality, and it is also a coding system that you can use to compare different, let's say, for example, language versions of survey items. I will explain all these three in more detail in a moment. Just want to give you a little bit of background here to show you that SQP is not just a tool that was developed 2 years ago and bam, it's out here. No, it's actually based on research that started already in the 80s with Saris and colleagues, who conducted and analyzed a series of MTMM experiments, basically or mostly conducted in the Netherlands, Austria, Germany, England, and so on. And they thought, okay, we have these experiments, we have the quality estimates, we have an idea of what potential characteristics might influence or lead to a certain quality. So why don't we come up with a very practical hands-on tool to give to researchers that they can use to predict the quality of their newly developed questions based on the questions' characteristics. And so they did a lot of research and conducted all these experiments. And then in the beginning of the 2000s, they developed the first version of SQP. Back then developed for DOS, and basically the prediction algorithm which was implemented in SQP was based on 87 of these MTMM experiments in English, German, and Dutch. It was a linear regression model. Yeah, so you would just plug in the characteristics of your question, trying to get to the quality estimate. And then a few years later, they programmed it or they released it also for Windows. And then again, a few more years later, in 2011, the version SQP 2.0 was released, which then did not only include these 87 MTMM experiments, but an additional more or less 250 MTMM experiments that came from the European Social Survey. And now the prediction algorithm was no longer based on linear regression, but actually on machine learning methods and very specifically a random forest model. And now the software was able to do this prediction for 22 countries and 21 languages. It was also awarded the APERS J. Metowski Innovators Award. And then there was a small usability makeover. SQP 2.1 was released. And about 3 years ago or so, the software, which was at that time hosted in Barcelona by the Universitat Pompeu Fabra, UPF, then moved to GESIS, where we have developed the next version, SQP 3.0, which involves now more than 600 MTMM experiments and is able to predict the quality of survey items for 33 countries and 28 languages. This here is a list of the potential characteristics that could influence the response behavior. And I don't want to go through all these separate things you see here on the slide, but what I want to draw your attention to is that there are different things or groups, let's say, where you might, or that might have an influence or might affect the quality of your survey item. Obviously, language and country might have an effect on how people react to the survey item or how they understand it. Then the trade, which refers to the domain and the concept. I did say earlier that this is dependent on the study. You cannot really choose, but still it has an effect also on the quality. So if you just think about things that are maybe more salient to the respondent or less salient, then the answer probably, or the quality of how they answer, is also different. Whether you ask about something that was in the past or in the future or referring to the current state, of course, also makes a difference. And then there's different things, additional components or things that refer to the linguistic complexity of how the survey item is designed. But then very importantly, it's the actual formulation of your request for an answer. Is it a direct or an indirect request? Is there no request because maybe it's the second item of a battery, and so on and so forth. And then there is all these different characteristics that refer to the response scale, which might have an effect. Also, visual aids will change the quality of your question. And then there's also all the questionnaire context. So whether you are fielding your questionnaire or your survey in a certain administrative mode, and so on and so forth. Will you have an interviewer? Will it be computer assisted? Also, maybe whether the person actually sees the item or just hears the item also makes a difference, or potentially makes a difference. So, and all these characteristics you see here, these are the characteristics that are implemented in SQP that, from a theoretical perspective, might have an influence on these on the quality. Okay, so from the program's perspective, SQP works the following way, or was developed in the following way. First of all the existing knowledge about the quality of survey questions or survey items was collected, which are all these MTMM experiments. Here you see also now that maybe 600 MTMM experiments doesn't sound so much, but it actually equals up to more than 6,000 questions or 6,000 survey items. Then all these experiments were analyzed, so in terms of the quality that was estimated, and then also all the formal characteristics of these questions were coded. So all these characteristics you saw on the slide before were coded for each of these 6,000 questions. And then based on this information, something like a meta-analysis was conducted over all these experiments. And based on this meta-analysis, a prediction algorithm was developed that then was implemented in the software. So, developed based on real data. Okay. This now is SQP from the user's perspective. So, let's say you now want to use the software. What you do is you insert the item that you want the quality of. Then you code your item along this list of different characteristics. This is the input that you give to the program. I like to compare it to the weather forecast, right? So in order to get a prediction of the weather for tomorrow, the model also needs some input data, such as what's the temperature right now, the wind is coming from where and what strength, and so on and so forth. And then this prediction algorithm implemented in SQP, so this random forest model, which again was developed based on all these MTMM experiments, gives you as an output the quality prediction, which is the product of reliability and validity. Just want to highlight here for a moment that the software is meant to predict the quality of attitudinal questions. I will say a few words about this at the end of this presentation as well, but maybe just for you to keep it in mind. Having said this, many roads lead to Rome. And obviously, there are other ways of testing whether your survey item is good or bad or works well or falls short in a certain way, such as expert review, cognitive pretesting, web probing, and so on. All of those which are designed to give you also an idea about the content, whether your participants understand the question in a given way or not. SQP is not so much about the content. SQP is really about, let's say, you already know the content is understood well by your participants or in the way you intended. Then SQP is a way of checking all these other little design choices, such as your number of points in your answer scale and things like that, that helps you in then improving on a more, let's say, formal level your question. So it's an additional tool and not meant to substitute any of these others, any of the other tools, but it's really an additional tool that can help you improve your questions even further. Okay, here on the right top, you already have the link for SQP. As I said, it's free to use. You can also browse through the database without any problems. If you want to use specific functions of SQP, you do have to create a user account and then log in. But for just exploring the database, you don't need an account. SQP basically has 3 different areas of application. The first one is you can use it as a dictionary. So it's a searchable database that you can use while designing your questionnaire. It's also an evaluation tool, which allows you to predict and then to compare qualities across different versions of your item. And you can also use it as a translation check tool. Meaning, if you have 2 versions or 2 different, or let's say you have one, your source item and it's being translated into another language, and these 2 versions are coded, you can compare whether the formal characteristics are the same or not. And all these 3 different application areas I want to show you now in more depth. So the first one is about how you can use SQP as a dictionary for survey items. This here is a screenshot of what the database or the upper part of the database looks like. You have different filters, so very basic filters such as which study does the item belong to, whether it's a question you put into the system or somebody else, which language, which country, and whether it already has a quality prediction or not. And then you have these advanced filters. So what I circled here in the pink box is the text filter. You can just type in text as it already suggests. And then the filter on the right side with the blue box around, this is maybe a more interesting filter from a survey methodological perspective, because here you can search for specific characteristics of your survey question. So SQP as a searchable database. In this screenshot here, I selected as a language English. I typed in the text filter satisfied, and in the coding characteristics filter, I wanted to look for an item in the database that actually uses a bipolar scale. I selected these things. I hit the Apply Filters button. You see then afterwards in this 3rd row, let's say, where it says Applied Filters, which filters are actually at work at the moment. And then underneath you will find the questions that fulfill these criteria. I brought you this example here. And on the whole, how satisfied are you with the way democracy works in Britain? The UK use the same card. Answer options range from dissatisfied to satisfied. Okay, so my question is in English. It includes the word satisfied, and it is indeed a bipolar scale. You also see there is already an authorized quality prediction right there in the system. So you can use already this quality prediction, or you can create your own quality prediction by clicking on this little pencil icon that you see there on the right side. Just want to highlight that though I find this filter super useful, indeed, what the system gives back to you, the filtering, is based on all the codings. So if another person has coded this question and coded one specific characteristic in the wrong way, then it might also show up for this other setting. And then you might wonder, okay, I selected a bipolar scale, now I have a unipolar scale here. This is not because SQP doesn't work, it's because it was a decision when implementing the search algorithm that it's being based on all the codings, also all the user codings. So you still have to think, but it's like using a GPS system in the car. Sometimes it works very well, but if Google Maps tells you to drive into a lake, you also wouldn't do it. So sometimes you still have to keep your mind in place and think about these things. Okay, SQP as an evaluation tool. I brought you here again, 2 different versions of one item. Here, using this card, do you think that most people would try to take advantage of you if they got the chance, or would they try to be fair? You have here this 11-point scale, or here, slightly different phrasing of the same question, but the most obvious difference is here the answer scale, which now only has 2 options. And when you look at those 2 and their quality predictions, you do see that the first question has a higher quality prediction, namely 0.58, than the second one, namely 0.525. So again, here, the conclusion you would draw from this is that you would go for the first item version. And last but not least, this is the third way of using SQP as a translation check tool. Here, especially when you work in cross-national studies or studies that involve different languages, the main aim is to keep the comparability about all these different languages or countries as high as possible. And SQP allows you here basically to compare these formal characteristics between the translated item and the source item, or the different items between different countries or whatever. And when you compare these different codings, you might detect differences. Well, you most probably will detect differences. And it could be that these differences point to the fact that there are differences or even mistakes maybe in the translation process. Doesn't mean that's the wrong translation, but it means that questionnaire translation is a very specific type of translation, and maybe a specific translator was not aware of all these different properties scales can have, for example. Then this person didn't have this in mind when translating, but was more focusing on the content and on how well it sounds and things like that. So it could be that here you detect formal differences, and then you can go back to the translator and say, look, this here should be translated in a different way, and then being aware of it, then also the translation can be corrected. Could also be that this difference is due to the language or the societal context itself, and that it cannot be corrected because it is right. Yeah, maybe one concept in one language exists in a bipolar way and in another one just in a unipolar way. So you cannot fix it, but you can keep it in mind when analyzing the data later on. This is what this could look like if you try to compare different versions here. This time it's the item, the English item from ESS round 5 on trust in police. If a violent crime were to occur near to where you live and the police were called, how slowly or quickly do you think they would arrive at the scene? Choose your answers from this card, where 0 means very slowly and 4 means very quickly. And this question here now is compared to the Catalan version in Spain. Si succeis un delicte amb violència a prop d'on viu vostè i truquessin a la policia, com de lent o ràpid creu que arribaria a lloc de delicte, and so on and so forth. And then if you would scroll down farther, you would again see this type of table on the left side, the different characteristics with the specific codings in the columns of the first question and the second question. Again, whenever you see these this background color, this means that there are differences in the coding between these two versions. The question is, are these differences problematic? Well, you decide. I don't know whether they're problematic. It is something that you need your own judgment for. Okay, wrapping up some final words about the limitations. Of course, I think that SQP is very useful, but it has some limitations. For example, it is only meant to be used for measuring continuous latent variables. So whenever you're measuring something factual or observable questions, such as demographics, facts, behavioral questions, SQP is not meant for that. So please don't use it for this. It will the prediction will not be good, not be very accurate. It can also not substitute any cognitive pretesting. So please, or expert review or web probing techniques. So please use those. This is really only for formal characteristics. It's also an empirical program aimed at prediction and not explanation. And it's limited to the type of questions that were part of these MTMM experiments. Summing up, you input basically your question and the codings. The prediction algorithm then gives you as an output the quality prediction. You can use SQP as a dictionary because it is a searchable database, as an evaluation tool because it predicts item quality, and as a translation check tool when you want to compare different language versions. But SQP is more than just a software. I also want to state this here. It's an ongoing research project with also a lot of possibilities to collaborate. So if you feel now motivated or psyched about this idea of SQP, feel free to get in touch with us. There's also tons of data that we are willing to share, to analyze, or for writing papers together or you alone. So please get in touch. And just one last thing, there is a huge team behind SQP, and this is just a few pictures of all these people that have been involved over the last, 40 years in developing this software. And with this, I want to close and thank you for your attention.